Okay, can everybody see a opening of Make Something Real with Textron on it?
Yep, we can see it.
Okay, very good. Well, hey, good morning, everyone, and thank you for joining. Apologies for a little delay here. Let's get right into it. And the first thing that I'm going to show, and hopefully the audio projects, is a gratuitous recruiting video.
Powering possibilities. It means moving faster, operating at full throttle, soaring to greater heights in the air, on land, and in the water. It means putting the customer first, delivering unmatched solutions and support whenever, wherever they're needed, around the world. It means listening every day, innovating every day. At Textron, we're pushing the limits, breaking the barriers. We're powering people, performance, results, success. Textron, powering possibilities.
Okay, it looks like there's a little bit of latency on that. So if anyone would like to look at the high resolution video, it's out there. But what I wanted to do is to provide some context to the discussion of just show a little bit of the products that we do at Textron and some of the, the title of this presentation a little bit leading. This is in my job function. These are the types of things that we make. And generally at Textron, we make complex stuff. And that's complex stuff carries people into hazardous situations across the globe every minute of every day of the year. And if that equipment breaks or the system fails onto it, it's not like you're pulling off to the side of the road and calling AAA for help. This stuff has to work. It has to overcome gravity. It has to be able to operate in very complex environments. So that's the context that I want to talk about today of a few things. And there's a great read, and you can either listen to it or you can take a look at the Wikipedia summary, or you can read the entire book. But Thomas Friedman, who is I would say a journalist who specializes in technology, has a book out, or a thing of The World is Flat. It's an interesting read, and there's some very good points to be made in it. But I think the most thing that I agree is that the world absolutely is flat. Okay, it is as flat as the picture that every one of you are seeing on your screen right now. And the reason why it's flat, if you think about it, in the truest sense of the word, if you think about how people showed up in, I would say, North America or the Americas continent, right? In the very, very beginning, right, they literally had to walk. Okay, and it took thousands of years for people, communications, or whatever to actually spread across the planet, right? And at that time, the world was a remarkably big place. And in advances in transportation, you move from walking to, using horses, using sailboats, using steamships, using trains, and then ultimately aviation. The world becomes a smaller and smaller place. So you take a look at modes of transportation that have made the world very flat. You can get virtually anywhere in the world in a very short time now. And if you take a look at the next little thing, the internet sealed the deal. So you now have the ability to instantaneously communicate wherever in the globe. We've got, I think, I don't know how many users that we have on here ready to listen to this session. Don't know where you're located, but actually you could be located anywhere on the planet and communicating on that, right? When I first went to college, right, I got money from my parents to live by picking up the phone, which I had to share with 30 people on one telephone call a week because it was charged by the minute. And my parents would actually write a check, put it in an envelope, put a stamp on it. I would wait for that and to come back. For my oldest, or my youngest in college right now, we Venmo, Cash, or Zelle it, and instantaneously it shows up. So the world has become remarkably small, and it is that flattening type of item. And in Friedman's work, what you'll see in those items is that in this type of environment of a very flat world, okay, where things are happening at literally the speed of light, is that finding jobs and leading in a new economy, this new economy of a flat world, requires engineers who can lead change, think across disciplines, interact with others, work across cultural differences, and always learn and grow. Okay, because the world is a very flat place. And factually, if you think about it, if you move from Cartesian coordinates to spherical coordinates, fix R, and you can describe anything on the planet in 2 dimensions. It's flat. Okay, a little bit of a movement of a frame of reference is that our typical thinking, okay, our typical training is to think in 3 dimensions, X, Y, Z. But if you convert yourself to spherical coordinates, you look at the world a different way. Okay, so the little kind of trick here in terms of joining the Flat Earth Society, if we want to take that a survey poll on that front, is we're all members of the Flat Earth Society if we change our frame of reference. Now, the other great quote from Friedman in a different item, this was in Deloitte Review, is give me a young person or employee with a high passion quotient and high curiosity quotient, high PQ and CQ, and I'll take them over a person with high intelligence quotient 7 days a week. So this is IEEE Eta Kappa Nu, right? Every one of you is a high performer. So here's the reality. There's probably 10,000, maybe 100,000 people who are just as smart as you are in the world. How are you going to distinguish yourself? How are you going to be competitive, influence, and make an impact, right? It's not just the intelligence quotient. It's how curious you are, how passionate you are. It's how your emotional quotient, how well you can communicate with each other, right? Because that's the stuff that allows things to get done at the speed of light. So I'm going to provide some perspectives on leading change. My current position is as Senior Vice President Technical Counsel. I've served in various capacities, increasing capacity of responsibility, starting out as an engineer at GE Aircraft Engines, working on a subcomponent, to leading an engineering organization, leading a global engineering organization, leading businesses, and transitioning back and forth. And the words, Senior Vice President Technical Counsel, I'm not a lawyer, right? However, I've had to engage with the legal community enough to understand that context. I remain an engineer, and my job is to literally counsel our CEO on technology and what decisions that we're making. So I'm going to provide some perspectives on leading change in the context of a technical environment. And I guess the very first and most fundamental thing, right, is that for the folks of you who are entering the workplace or in the workplace, or any time in your careers, if you make it very simple into an XY graph, right, is that you're going to spend somebody's time and money, some level of effort on the x-axis, and you're expected to improve performance. That's the simplest things. However, if you spend time and money and you actually result in a different state and you actually decrease performance, you kind of have to question, okay, how long is somebody giving me time and money to do that? And then there's another outcome, is that you actually don't make a change. You actually spend time and money and you figure out you can't do anything else and performance is unchanged. So the only one in this scenario where the objective is a performance increase that has a return on investment is the one that takes it to a higher performance state. Let's make it a little bit more complicated. What if your measurement is affordability? And in many cases, right, affordability is kind of on a different type of label set than performance, right? Very hard to make a car that performs like a Lamborghini only costs $2,000 if the objective is to bring transportation to the masses, right? So performance contract match. Very hard to make an aircraft that is supersonic at the price at one that flies at 150 knots, okay? So some of those are contradictory. Then there's a probability of success. Okay, you're going to spend time and effort, and if the objective is to improve performance, make it more affordable, And we throw another challenge on there is, okay, let's make a spaceship that can exceed the speed of light and go warp factor 2. Probably a success in that environment ends up probably being pretty low because there's some physics there that folks say is rather challenging to overcome. And then let's take another measure of it, which is airworthiness. Say we're going to make a change to an aircraft system. Textron makes aircraft, makes fixed wing, rotating wing, and tilt rotor aircraft. And any change that you make to a proven system puts you into a state of unknown airworthiness. So in this concept of change, what I'm trying to convey here is that we're going to spend time and money trying to affect something that's got a lot of dimensions to it. And the question is, are you understanding the dimensions of these changes that you need to address? Do you understand the weighting factors on it? And what's your measure of success? So leading change in this environment on complex systems it's really a multi-level, multi-dimensional problem on very complex products. So if you take a look at the aviation sector, where I've spent a lot of my time, it's not just the technology, it's will the consumers accept it? Does the regulatory framework understand what it is? Is the infrastructure there to be able to handle it, right? You can't just put a fixed wing aircraft out there without an airfield. So if you develop a new aircraft, which requires a longer runway, and there are no long runways, it's there. If you're going to put an electric car onto the market and there is no charging station, very hard to make a successful product. And then, right, and you have the legal and litigation infrastructure, which kind of ties into the consumer acceptance and how risky is this item, right? So for those of you who are associated with the aviation field or the automotive field or the medical field or you name it, right, there are all these different things and considerations there as you kind of develop things and make an impact on change. So let's put another layer to it. Okay, if you talk about just the fact that consumer acceptance in regulatory environments, virtually every country is a little bit different. So what kind of change are we talking about? Okay, in terms of the product or the technology or whatever to it, and where? Okay, because the regulatory environment in the US and Brazil, China, EU, Australia, you pick the country, is likely different, and the consumer acceptance factors are likely different. Okay, and it's just a very different environment. So how can you be successful in managing change and introducing new technology in these environments? And it's extremely important to kind of understand what these dimensions are in order to be successful in these items. So I'm going to go through a few case studies and try to be mindful of everybody's time. This presentation is a derivative of one that I do at Penn State in their engineering leadership program, and we spend a good hour and a half plus Q&A on it. So one that I've been intimately involved in, being in the aviation sector, is a topic called unleaded avgas. And if there's any pilots or folks who fly small aircraft on there, you might know what 100 LL is, 100 low lead. And it's a very interesting problem set. So I'm an aerospace major. You kind of have to pick what your favorite aircraft is. And one of my favorite aircraft is the P-51 Mustang. And the reason why it's one of my favorite aircraft is it's not just the aircraft, it represented at the time an optimization of the pilot capabilities, the aircraft, the development of a new engine, and the development of a fuel that made that engine aircraft system possible, right? So this aircraft arrived at the optimization of some brilliant thinking by not just an aircraft engineer, but actually it was enabled by a brilliant chemist who figured out that a little bit of tetraethyl lead added to a hydrocarbon greatly improved the performance properties, which allowed an engine to be developed to make an anti-gravity drive for an airplane that did very special things. Okay, and actually helped achieve kind of air superiority and turn the tide of war in that state. So, however, right, that tetraethyl lead remains today the single largest source of lead pollution and emissions in the United States. Tetraethyl lead is a neurotoxin. If you ingest it, it causes problems with your neural pathways, and it causes significant problems in children's brain development. Okay, and in adults, it'll put you in the hospital and kill you in the right levels, right? And this is the secret ingredient that's in avgas for small aircraft, and it allows them to do things that they can do, and it's the single largest source. And around the 2007 timeframe, the Friends of the Earth and the American Pediatric Society sued the EPA to say, this really isn't a good thing and we ought to take that out. Okay. So I don't know if the polls are operating, or if I have to click the special Klingon there, is that there's a question up there, right? So the other thing about this is that that lead allows aircraft to perform. So in the same time frame that we were talking about this, I was on Capitol Hill and this subject came up of we need to remove the lead from avgas. And I was in Congressman Young from Alaska's office. And he said, what do you not understand? That the communities that I serve in Alaska don't have roads between them. So if you no longer have aircraft capable of carrying food or medicine to the rural communities that we deal with in Alaska, what don't you understand about that? So the poll question here, right, is that you have a case where we have a performance modifier of the fuel that allows these aircraft to carry people, medicine, food, supplies to vast areas of the planet, not just Alaska, but you talk about very wide stretches of the earth where they depend upon aviation to get stuff to people. And these are small aircraft putzing around. Okay. And this is a most recent example of one that just developed and came to the market, which is flown by Cape Air, but serves rural essential services in the United States, connecting remote communities to more major airports to get essential services to it. So in this case, we have a problem. Lead is a neurotoxin. However, we take it out, we can't have the aircraft perform. Some of them can't fly safely. And now we can't get food or medicine to rural areas in time. So you're an engineering leader on this problem set, or you're a congressional leader. What's your choice? Are we going to continue to poison our children, or are we going to starve our people? So this is a problem. Okay, we recognize, okay, that it's a neurotoxin. We need to do something. The question is how we do it. And the reality of it is there was a triggering event in 2010. And there was a lot of efforts formed to it and a lot of smart engineers and a lot of folks taking a look at the problem. And you just kind of set your timeline and you go solve it. However, a decade later, okay, there was not a solution on the market. We had lots of changes in administrations and viewpoints on the EPA and that processes there. But one decade later, Congress is wondering, okay, why haven't we solved this problem? And let's get the National Academy of Sciences to go take a look at it. So another set of really smart people set up to go take a look at it and see what we could do. Okay, so one decade later, actually 12 years later, because now we're in 2022, and we now have another effort to say, okay, how can we solve this problem? Because you know what? It's not acceptable to continue poisoning our children, and it's not acceptable to starve our people. Okay, so how can we continue to go address this problem? This is one that's got a lot of history to it. You can Google my name, you can Google 100 LL avgas and unleaded and see all the efforts onto this. The fact of the matter is there's been remarkable progress. However, the fact of the matter is this is an incredibly hard problem, which comes down to one brilliant chemist's idea that tetraethyl lead could greatly improve the performance of a fuel, okay, which has served aviation extremely well, and actually automotive extremely well for decades. And now we got to try to find a different solution. It's hard. Next case study. And this is one in decision management. And for the folks that aren't familiar with the Space Shuttle Columbia STS-107 mission, the Columbia broke up on reentry to the atmosphere with a total loss of the astronauts. The background story on this is that in the Space Shuttle transportation system, you have obviously liquid propellant rocket motors and you have solid propellant rocket motors. And the liquid propellant motor on that external tank, liquid hydrogen, liquid oxygen, humid air in Florida, you develop a lot of ice on the outside of it. Well, it was always known that ice would develop on the outside of the booster, and on takeoff, chunks of that ice would fall off, and you literally have cameras taking a look at the trajectory of those ice chunks coming off and whether they could potentially impact the bottom of the space shuttle and compromise the heat shield system on the space shuttle. On STS-107, the engineers taking a look at the camera said, geez, there's a high probability that a chunk that was larger than normal on a trajectory that could have impacted the bottom of the space shuttle, and we may have a compromised situation on the heat protection shield. So imagine yourself in this case of 7 astronauts in the spacecraft, and you have a decision to make. In space, there are no refilling stations, and as the time clicks, you are running out of oxygen and fuel, the ability to maneuver. So in this case, you're sitting there as the mission controller, and there's a great case study on this, that actually I keep on the upper left-hand side of my desk as a continual reminder on the importance of making decisions in time to make an impact. Imagine yourself as the mission controller. What information do you share, and what are your options? Do you allow the astronauts to burn up in the atmosphere on reentry because of a compromised situation, potentially compromised situation? You allow them to run out of oxygen. And how quickly do you make a decision? And is there any decision you can make quickly that gives you alternatives before these things? Because once again, you're using up oxygen and you're using up energy, which is fuel. So any minute that you have is consuming critical resources for you to go execute alternate options. Could you make a dash to the International Space Station? Is there any other option to assess the state of the heat shield system below? Which extravehicular activity is also going to consume up pressure and resources. So this is where the leader is sitting on these types of things, of critical decisions which impact lives. Let's go to another one. Again, being mindful of people's times. It's the 737 MAX, which is how many dimensions you really control. So history of 737 MAX, which is still being written, and I would caution everyone here to be careful, because the history of understanding what happened on the 737 MAX is still going to be written for a few years to come. However, if you take a look at, Fox News, CNN, whatever, you have a whole bunch of experts at that time indicating, common sense to ground the 737 MAX 8, an aircraft that at that time had executed tens of thousands of missions, carrying passengers for 59 different airlines with hundreds of different pilots, successfully without a crash. And then on 19 March 2019, after 2 accidents and hundreds of deaths, you find this in the Seattle Times. I don't know if anybody on this line works for Boeing or intends to work for Boeing, but how would you like to wake up one morning with this on the headlines and somebody in the Seattle Times writing that the MCAS system at the center of investigation of 2 fatal crashes was misunderstood, mischaracterized, and a flawed certification process as Boeing and the FAA rushed to bring the new jet to market? And then you see this in Fortune magazine as emails come out that the 737 MAX, designed by clowns, supervised by monkeys. Boeing's own words. Anybody believe that Boeing engineers are really clowns? Difficult stuff. How would you like to be the lead engineer, the chief engineer, or the chief pilot on the 737 MAX? However, there's 2 crashes. 346 people are dead. Who's at fault? Somebody must be at fault, right? The world wants to know who is responsible for this. And go back to the diagram. Was it the pilots? Was it Boeing? Was it the FAA? Was it Lion Air? Was it Ethiopian Air? It certainly can't be the lawyers. Somebody must be at fault. 346 people are dead. Difficult stuff, and leading through these types of challenges and leading change and this is a new aircraft that went to market. It's highly efficient. It was an extremely efficient aircraft that reduces fuel consumption, reduces pollution, everything else. And it included feature sets on it which made that 737 safer than it ever was before. But something went wrong. So the history on this is still being written. Okay. And I would caution that, looking at this from the outside, very difficult to see it. And there's a lot of different things moving on, but these are complex systems of systems. Everything has to go right. And a very good article that's out there is what really brought down the 737 MAX. It's a combination of events, of the assumptions behind this multidimensional problem where something went wrong, right? One of the things that went wrong was an underestimation that pilot training programs in certain countries are different, and it's set by the local civil aviation authority, right? So the assumptions, and this gets back to the communication and operating in a global environment, right? An assumption that all pilot training is the same around the globe turned out to be an incorrect assumption. Okay, an assumption which ultimately a pilot's ability to handle multiple cascading malfunctions or take different actions in the cockpit turned out to be wrong, right? So the answer is everybody in this system of systems had a role to play in understanding what the total dynamic was to ensure that that happens, right? So Boeing engineers aren't really clowns, and there are no monkeys there. The misunderstanding and the communication thing was started on a very small assumption not being applicable and then cascading into other things where the system couldn't accommodate that, including maintenance practices at the things and training and everything else. So very difficult stuff. So there's a lot of reminders here as they've gone through their careers, but some of these, and I'll group them. Change is necessary, right? We had to kind of adapt at the beginning of this talk to some technical difficulties on it. It involves people. Their perspective may be different than yours. In this great global flat world, still doesn't mean everybody is the same. And same, better, worse can depend upon your perspective. The greater number of dimensions of change, the greater the need for leadership to navigate through it, and the more complex the change, the more likely engineering leadership is necessary to understand the complexities, right? Your training in complex multivariable control systems, okay, is essential to understanding complex problems, no matter what their nature is. And there's methods to apply and being able to do that, right? So the skill set that you have as engineers is essential to understanding complex systems of systems. And by the way, the world is a complex system of systems with people in it who don't understand the technology. Communication, 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 right? Leadership is a continuum. Followership counts, okay? You can be the leader, you can be on the team. Okay, leadership is not a dictatorship. Followership is not blind or conscious acquiescence of the leader. It's not follow the leader. It's help make your leader successful in the decision-making process. And sometimes leaders are wrong, and you need to help them arrive at those solutions. And there's a time to understand in the context is that your job is to reach fact-based consensus, right? First, you got to agree on where you're going to get your facts, not Facebook, not TikTok, not YouTube, not whatever it is, okay? Facts are facts. You can have your own opinion, but you can't have your own facts. But you got to agree on where you get your facts. Because technical decisions are not taken by majority vote, okay? You don't vote on whether F equals MA, right? Engineering crowd, we all know that's an approximation with a lot of assumptions on it. However, you're not voting on that, whether that's true or not. It is true. The question is under what assumptions does it remain truer, right? You need to enable your teams to reach fact-based consensus. You don't vote on physics. And above all, leadership needs to enable decisions in time to have an impact on the outcome. A decision too late has grave consequences to it. So understand the dimensions, understand the time frame that you need to make the decision, understand that you need to make fact-based consensus on your best set of facts that you have at the date, and decide. Okay, critical as you go through this. Okay, and critical to communicate along the path to try to bring people via any means necessary, explaining things in simple fashion to be able to bring on a crew that may not, to bring on the audience that may not understand the complexity of the issues that you're dealing with. So in the big picture, right, I view my job as an engineering leader is to make a complex, flat world governed by unforgiving physics a better place by navigating through difficult decisions in time to have an impact. That is a heck of a run-on sentence, but that's really how I boil down okay, is my responsibility as an engineering leader and technical counsel within Textron and Textron Systems. This is my job. And along that path, I may very well come across a breakthrough innovation. As an engineer, I am not in this world, okay, to come up with the next best thing. I am in this world to make the world a better place. And that's the context by which I approach my job and the leadership and the technical counsel that I provide. Because the earth really isn't flat, okay? Things are happening at the speed of light, but the earth isn't flat, okay? There are genuine things to take advantage of here with folks in the very, remote areas of the planet, separated by great distance, communicating in real time, which makes it very hard. You can't fix the world at the speed of light, okay? And this is a really hard problem, which our generation and my previous generations have used the planet in ways, okay, that may not make sustainable development possible. And this isn't climate change, right? So back again, the facts are the facts, right? Global warming, climate change, those are very things that are very hard to define. But the common thing here, which is in a great paper issued by the United Nations in 1987 on sustainable development, is how do we keep this thing going, right? So there's a poll question up there. Do we save the earth? Or I think it should be capital Earth. The earth is just going to be fine without us. That gets to the crux of sustainable development. That's an incredibly hard multidimensional problem, which many folks aren't pulling from the fact base, okay? That the folks entering the workforce for the next 40 years, you're going to have some role in fixing it. Whether you understand your context in that or not, you're going to be part of that machine, okay? So overall, this is the reason why technical leadership in these hard, very hard decisions and complex systems, there is no more complex system than the planet, okay? And this is where your toolkits as engineers come front and center to be able to help navigate through this, explain it, deconflict it, and make fact-based consensus decisions on what we need to do to go forward, no matter what problem set you're faced with. Okay, so thank you. Be curious, be passionate, don't hesitate to lead. So I don't know if we have time for chat or Q&A on the items here, but if no questions, anything, thank you very much for the opportunity. These challenges resolve a lot of heavy lifting to work, and most importantly, engineers who can understand these complex issues to be able to support the team, support their leaders, and lead to make these decisions in time to have an impact.
Hi, Mike and everyone. We have about 12 minutes before the session ends. So if anyone has a question for Mike, please put it in the Q&A section and we will read them out loud.